Welcome to the last session of our such a long day that we've had today. I hope that the ideas that we present here through our wonderful speakers generate a lot of interest in our audience, and we would like to see many questions from you. We are on the education of development of geospatial information. I'm sorry, that's the presentation. Education and capacity building to leverage geospatial information. This is about education and development of capacities for geospatial information. So I'm here with Dr. Pilar Gomez and Doctor in Engineering Alejandra López Caloca. And we will begin with our international speaker, Pilar Gomez. She was born in Southern in Catalonia. She has a degree in geography, PhD in pedagogy, and geography by the same university since 1989 until 1998. She was an associate professor of cartography in the Department of Geography at University of Barcelona. As an associate professor in geography education. Since 2000, she teaches geography in the University of Barcelona, where she teaches geography in the master's degree and the research master's program on social science. She is the director of innovation projects at a private foundation commissioned by the Autonomous University of Barcelona. And she is currently teaching social science education in the School of Education for language, literature, and social sciences, I guess, in the University of Barcelona. Pilar is going to present the paper entitled Education and Development of Geospatial Capacities for a Sustainable World. Without further ado, we give the floor to Dr. Pilar. Welcome. First of all, thank you for inviting me to this international conference on geography, environment, and I have paid close attention in the subtitle, Geography and the Environment for Decision Making. With this, I think that I may be able to present some ideas that could give some light to this idea of education, capacity building for a sustainable world. In the cover, I have put the cover of the investigation team of Universidad Autónoma de Barcelona. It is called Alteris, which in Latin means with others and for others. And that's one of the keys of this presentation. First of all, when we want to present a lecture, we want to make some questions. I have chosen these 3 questions in this case. How does the activation of geospatial capacity works in the digital capacity, cognitively speaking? And with this, I'm saying that something has changed. we will see what it is. How can we teach them in the most appropriate way? And how can we collaborate to the sustainable development from the way we teach them? After these questions, we have some ideas. The idea is mainly, in summary, something that reinforces the three ideas. The first idea is these geospatial capacities, we understand them as those who can allow us to think and solve spatial problems. The second idea is that it requires a functional learning environment and argumentative environment. And finally, we understand that it is a learning process that is based in real problems and where the student may have an emotional and cognitive implication. I've wanted to read the three definitions because when you are giving a lecture, it's an argumentative process which begins with some statements and it ends with some conclusions. In the middle, we need to justify what we're saying, and this is what I'm going to do. In summary, these ideas are not based on a personal opinion, of course, but they are well-founded on and contrasted with authority arguments, like the ones suggested by different authors and paradigms, which are being interwoven and interlinked, creating what, in my opinion, is a new paradigm in terms of education, which I would call humanism of the co-society. I don't know if you've learned some things that refer to this. The 21st century is the century of the co-society, collaboration, cooperation, always with this prefix of CO. We are always showing this linkage through all the expressions in our terms that will take us to a society that is focusing on this kind of work. In these days, in the different presentations, I've also witnessed that in one way or the other, we all agree on the fact that the model, the geoinformation model, is based on collaboration of all the actors, especially the youngsters. We are before a social challenge, an authentic revolution with different paradigms that interact, different ways to see the world, and considering the basic characteristics of the society. On one hand, we have the network society. Manolo Castells is a specialist on this information society, and I'm pleased to say that he is a good fellow citizen from Spain, and he defines the network, not the network society, not only as a society that is marked by the technological revolution of the internet, but he also highlights that the network society is that which has the opportunity to have certain social structures that are more horizontal, less hierarchical, and this is a very important element. It gives us the opportunity to organize our society with structures that are not hierarchical. I'm not saying that they're absolutely horizontal, but because that would be an utopia, but they're more and more democratic. And we are before a very important social challenge, which is sustainability. Sustainability is also a utopia, but it is a need at the same time. And this sustainability is what we have as an aim as the human space to make a better world for all of us. And this sustainability also gives us a change of orientation from an anthropocentric way of thinking to the environment-based way of thinking. And I think that in this way of thinking, we may find a balance and we will be able to survive. As you know, geographic education is focused on this sustainability. We have the concept of space intelligence. Yes, the concept of intelligence has changed in the last years. I'm sure that you know the papers of Howard Gardner talking about multiple intelligences, and it sets a model of intelligence that is based on 8 types of intelligence, one of them being the space intelligence. But Howard Gardner says 3 important ideas. Apart from the multiple intelligence concept, on the other hand, he also presents an idea that intelligence is not genetic. It's not only genetic. And the base of experience, opportunity to learn along your life is very important as well. And he also presents something very interesting. The most interesting idea, in my opinion, by Howard Gardner is the definition of intelligence for him is the capacity to solve problems in the environment of an individual. And that means that we are seeing intelligence in a more functional fashion, in a more applicable way, and more accessible for everyone. It's not having an IQ, a certain IQ for math skills and logic thinking, but an individual, on the other hand, is someone who has a more flexible mind that knows how to operate in an environment and to collaborate and help this environment to improve. And to conclude, the other model or the other base of inspiration that we use in our team is the theory of complexity. You know that Edgar Morin is an inspiring philosopher, really inspiring, and he proposes that we see that complexity with which we usually define our world as something not as something complex, complicated, difficult, but something with some intimate weave in it. Edgar has also presented another idea that we use as a theoretical base of our work. Edgar goes beyond this holistic approach, and he says that you can find everything in this essence, and the sum of the parts makes much more than simply the sum of the different units. That whole that is created by a good team that know when to collaborate effectively to create a project is much more than the sum of the effort of several individuals. So in order to leave aside theory, we will not go to justify my ideas from another point of view, a completely different point of view, with some examples. In this case, this is a drawing by Juan. It's a drawing of a 6-year-old who in 1992 was asked, when I was doing some field work for my PhD, he was proposed or asked to draw the planet Earth, the Earth, and see what is the map that he drew. It's a personal map, cognitive map, but it's a very interesting map. You know, this kind of sausage? What is it? What do you think it is? It looks like a very strange moon. He didn't tell me. He was very clear in explaining what it was. I asked one, what is it? Well, it's like a Spanish sausage, I said. What is it? And he said, well, Pilar, it's a satellite. Look at the way he even drew the orbits. And for me, this drawing was the main point of focus for my paper in my PhD, my final paper. I could say many things about this drawing. For example, thanks to this drawing, I was able to demonstrate that a 6-year-old is able to represent the world that they're living from this perspective of integration of the planet Earth as a whole, integrating also the technology. I mean, technology is integrated to this geography with the geographic space. And on the other hand, if you see, it also has some continents, and it presents these continents. What are continents? Big islands. And what is the first concept that a human will create? The concept of an island, because it's the more simple one. It's land surrounded by water with very well-defined limits, very specific and easy to draw, easy to identify. Land and water. And with a closed limit, because an island is a space that is completely closed. So why am I presenting this drawing? Well, to justify an idea that I think is very important to me, which is that we humans learn by reconstruction. Starting from our basic concepts. This has been studied by Vygotsky, but the past also continued with this work saying that we teach about through transmission, but what we do as humans is we modify something that we're taught through our mental activation. Something changes in our mind when our attention is caught. And this is very important because in order to teach geospatial capacities, we will need to consider the maps of each individual, the mental representation, not only maps, but also space ideas people have. Children, adults, or people of any age. So look at the way this 6-year-old had his own space theory. The world, his world, was integrated by a physical space and a technological space. And this is where the revolution we are living begins. I was saying before that in the cognitive aspect, many things have changed. You can see how Juan created this integration. 10 years before, probably a 6-year-old would have drawn something different. He would have drawn the planet Earth as a flat thing, a flat surface. But as Alejandro Pisticelli says, digital environments create a more intimate weave among action and thinking and incarnation. And I think this is a very interesting idea. I think all of these processes are accelerated, and they have a lot of essay and error. And classical geospatial capacities like orientation and representation are delegated to the navigator or other devices and applications. Like what? Like geography. Just classical geospace capacities have lost some functionality. The star ones would be the selection of geo information and handling technology devices. Would we say that? Would you agree? I'm not sure about that. I want to be more specific about this. So this is an analogy of the iceberg. When we talk about geospace capacities, what material is it made of? What specifically are the geospatial capacities? I've created this model. I could use another one, but it's to make a distinction between those capacities that are linked to space coordination, like orientation, representation, scale proportionality, etc., and the social conception, which is very important, and space communication. And the iceberg, the idea is that with this space concept will be more synced or down deeper into the communication, the space communication. And what has changed for the last years is our capacity or how easy we are able to communicate our space ideas through a graphic language and technology and semiotic instruments that are very powerful. Social consumption responds to a system of value and explanatory theory, which is the cosmovision of every person. Look at Mafalda. This character is saying, what have Souths done to deserve this Norths? So it's built about experience, emotional and rational. Space coordination, I want to say that it's very common to see that when we talk about space coordination, we talk about the orientation capacity of an individual. And it's also very common that we forget something. What is the most powerful orientation system we have? In my opinion, the most powerful one is the body corporation system, up, down, right, and left. And if you're not good in this laterality during the first 6 years of life, you will have a problem with that all your life to understand any navigation or even some devices. And it's a very important thing to note. In space communication, we of course need digital technologies that make our life easier. But it's not only about communication based on geo-information that is digital. I say again that it can be an effective communication through images, analogies, mind maps, etc. We don't have to just stick to or be limited to too much. As in the keynote lecture today, the speaker said this, and I think this is very interesting. I just want to give you some example of what we've done. 2 projects, mainly Xarxa. I'm sorry that it is in Catalan, but it's our official language, and we use it for education purposes. This project is based on the introduction of GPS and secondary school. It was a bigger project. It included training to professors At the same time, they would use what they were learning with their students, using that functionality and this energy exchange. And what we did, I just want to explain one case to present this as information. We chose a group of students, secondary school students that had a lot of learning problems. They didn't have enough motivation to have a good performance at school, and they were like a little bit lazy. And what we did is ask them to solve a problem. It was a very practical exercise. They were part of a group of students that year were going to have a trip for the Santiago path. They would follow an itinerary. And you know who did that itinerary? That group. And that group, well, they learned. But most of all, do you know what we got from that? That they were the leaders and the successful ones in front of their peers. And I tell you that because when we educate, I think that we have to activate different variables. And one of the most important ones is self-esteem. There is another project that started 10 years ago. It's called Rastros. In Catalan, it's tracks. It's a very simple one. Units are the names of the different municipalities. We have a problem with that. Students who live in urban areas or these scattered towns or villages where the central part of the municipality lives in one thing, but they have many scattered population. When we asked, what is your town? And they said the name of their area, not of the municipality. They were not aware that they were part of a municipality, and it was a serious problem. And when we saw that, we started to develop a project to make some groups with the students. Each group would choose some toponyms from their municipality. They would geolocalize them, place them in the map, describe the situation, and what they did was a small investigation of each one of these names with pictures, with orientations on how you could get there. I mean, directions, etymology, story, history, and everything. And the interesting thing about this project it was very useful to start with a methodology that is service learning, what we call today as service learning. Is a new concept. So that database that was not available back then was included in the website of the municipality, and it was presented publicly, and the mayor shook the hand of each citizen that made that possible. All these little researchers. In conclusion, I think that with the justification, I don't need to read my conclusions. I've taken too much time. But I think that I have presented my idea. So in summary, what do we defend? We defend that space capacities are different. They have a different hierarchy today, and the communication skills are incorporated as very important ones, and learning environments have to change. They cannot be just based on transmission and simple teaching about latitude and longitude. It's not just about orientation. We need to put our students or learners in the situation to be, most of all, citizens. And the most important part of this, thank you for your attention. Thank you, Doctor, for this brilliant presentation. And now we give the floor to Dr. Alejandra López Caloca, engineering PhD researcher of the Geo Center in Mexico. Dr. López Caloca is going to present. Could you please put the slide where you have the title?
Her work is the current trends of the analysis of multi-temporal, multi-sensor, and fusion data. So good afternoon to all of you. Thank you very much for the invitation. I thank the UNEGI and the UN for inviting me to participate in this event. And I'd like to talk about trends from an academic point of view and of the multi-temporal, multi-sensory, and fusion data analysis. What am I talking about? Well, as we all know, all of the advances in technology, including satellite advances, we have sensors that are continually taking measurements of the processes that happen on the Earth, the oceans, the surface, and the atmosphere. And they generate a great amount of data regarding these processes and how they work. But we don't have the same progress or advances in terms of interpreting the data. We have data, as I said, that we obtain from sensors, from satellite images, data in situ that we obtain in the field, and even data that has already been interpreted, or estimates of physical phenomena based on repeated observations. So the key challenge is to leverage all of this data by developing a working framework that will enable us to generate a consistent knowledge. In this sense, the fusion of data could be used to provide this complete panorama of the data that are provided by each sensor and how we can begin to extract information or reliable information from the sensors. In the sense of multifunctional capacities, the research community in data fusion has been studying more deeply, especially these concepts that you see here, which are multi-temporal, multispectral, multi-frequency, multipolarization, and multisensory. And in particular, I'd like to perhaps talk a little bit about each. From 2006 to 2012, these aspects have been redefined. For instance, we do know what our satellite images are, and we know, for instance, we talk about the multispectral aspects of the images, and what they're talking about is how objects behave in the different wavelengths of the electromagnetic spectrum in order to be able to analyze the behavior of those layers. Multipolarization refers to how we get information out of microwave images, and the polarization of a wave, electromagnetic wave, refers to an orientation of the electrical field. The multitemporal aspect is talking about the formation of a set of images or repeated images during a set period of time. This observation frequency depends greatly on the characteristics of the sensor itself and of the conditions of observation. And this is why when we have a capacity to distinguish a lot of dynamic processes. The multisensory aspect refers to the increasing number of operational and experimental satellites, the amount of data we have, and information as to the phenomena that can be captured by all of these or collected by all of these different sensors. And the main ideas of data fusion originate precisely in what are systematization, engineering, artificial intelligence, the theory of, cybernetics. And in order to be able to work with all of this information and data, we have to have some important considerations to be able to achieve that data integration. For instance, we have to carry out an alignment in terms of space and time in order to guarantee that the information that we are integrating and that we are merging has no errors. To associate these data is important, and to generate an adequate level, and this implies a common space-time reference. Given that the observations of the sensors and of the objects that are in movement can have measures that can be corrupted, then certain errors are generated, and therefore it will be necessary to do pre-processing, such as normalizing the data, correcting the atmospheric data, the calibration, etc. It's important to take into account that we must merge only such information that will enable us to follow in a coherent manner the sensors that we are working with. And it's also important to take into account that if the data are correlated or not. In this respect, we often use information that's original, and we use it many, many times as if they were independent data sets. As I was saying, the data fusion or data merger community has worked and has had very important achievements. In the concept of merger or fusion, there are some words that are key in English here, such as merging, combination, synergy, integration, information. All of them are present in the literature. And more recently, we've started to heard about a data fusion, a data merger, information fusion, sensor fusion, and information merging, or data merging. To understand how can we do this data merging, here I'm presenting a definition by Waltz and Linas in 1990. They said that the fusion or the merger is the combination of these data from different sources in an optimal manner. This merged information represents an entity with greater detail and less uncertainty of that which would be possible to obtain with just from one individual information source, and the additional combination of independent data and redundant data can provide an improvement in the results if it's conducted adequately. The JDL in 1997 defined it as that data merger is wait, I'm trying to see where she's reading. Okay, so it's a combination of data from different and distinct sensors. And they defined it again in 1997, but they began incorporating some of the keywords, such as improving precision and more specific inferences than those that can be obtained solely from one sensor. In 1998, Wald introduces the term of greater quality. And the idea is to have information that has greater quality because the application depends on the quality. Now, in the community of the data merger, in the data merger community, one of their biggest contributions is the JDL model, which represents an initial effort for a common terminology within the domain of data merger. And this began precisely in the military, trying to understand what were the synergies and the differences, how we could complement and collaborate and merge all of the data and understand them in order to be able to make adequate decisions. In this classification, the data are divided mainly into 4 levels. 0 level is what I was talking about a second ago, which is the pre-processing. And then after that, the other levels, there's an object level, where you work with the raw information, then another level that's known as assessing the situation, and the last, which is the impact of the data or the effect of the data. All of these levels are intercommunicate and interconnected, and this is a model that has had many variables and variants since it was proposed. Another important model was that of Dasarati in 1997, in which the levels are no longer interconnected, but rather they are represented as inputs and outputs. But the thing is that we have a level of merger that's called a low merger level to a high merger level. And Dasarati begins to define a basic merger level, which refers to information that is more original, more raw information, and a higher level refers to the taking of decisions. And what do I mean by all of this? Well, we want to be able to classify or integrate information in these extraction levels. At the low level, I would say that we start with a signal and then with pixels, and then a medium level would be characteristics, where we take the information, we extract its most important attributes, such as, for instance, forms, textures, positions, or even attributes that can refer more to spectral issues or aspects, such as retrodispersion coefficients, etc. All of these are used in other tasks. And the last level, which is the highest one, would be the symbol level, or the decision level. And at that level, we take all of these representations that are extracted from the information so that they can be combined, and especially for the taking of a priori decisions. I wanted to say that both data merger and data mining are complementary. Both contribute inductive and adductive capacities, and also deductive ones. But data merger is focused more on the deductive aspect, more on the detection aspect. And some examples of algorithms, such as, for instance, the genetic algorithms and trees. So the levels of merger processing, this is falls more within the framework of the Association of Geoscience, and we adopted what's known, what we call these levels: the merger level, the pixel level, the signal level, and then the characteristic level, and the merger level at the decision level. In this image, it's not included, but there's also issues that have to do with modeling. So the most basic level, we have some variants, such as, for instance, mergers in the spatial domain, the spectral domain, and then the time-space domain. So I'm going to show you some examples. What we do, for instance, in data merger in spatial domain and the spectral domain is that we try in a sensor that it can have multispectral images and a panchromatic image, but try to conserve the spectral information and incorporate into it the high resolution from the panchromatic image, so that the image is like a synthesis that has the same spectral information but with greater spatial resolution. And this is a methodology that is very much established, although we continue to do research. And the way in which this has been improving as far as the research is concerned is that, for instance, to include in mergers with a space scale, where we can break up or decompose an image at different levels by applying filters, and then we create rules for decisions so that we can combine the information, and after that we reconstruct the resulting image. These sorts of mechanisms are used very much with weblet transformations. These sorts of things that I've been talking about we do at the center where I work. For instance, the Green Urban Areas projects, we used it and leveraging the images, and so we conducted merger projects at the pixel level, and we used high-resolution images, and we merged that with the spectral information, always trying to conserve the multispectral aspects, and then go into classifications. If you can see the image that's classified, which is the green one all the way to the right, you can see that the green areas, and you can see the spaces between the green areas, and there are different tones of green. And this is a synthetic field. The merger methods based on transformation is something that we continue to do in the state-of-the-art information integration, and we're always seeking to introduce better details. There are different types of decomposing an image so that you can introduce the details of the information. And here, this is just an example with a transformation that we've developed that's called, I can't really read the slide, it's too far away. And anyway, many of the transformations that are occurring now is to incorporate how do you merge all of these synthetic products. With respect to detecting changes, there's very important work from Luzon and Bologna and several authors that are trying to see how all of this information can be incorporated into all of this framework that I've been talking about. If we talk about different sensors, well, it's not difficult to start thinking that we can integrate not just data in the optic region, but also in the microwave region. We've proposed mechanisms of integrating radar images where integration processes include aspects that have to do with noise reduction. This is a small example of how you can carry out an integration that only has to do with the details of edges and lines towards multispectral images. These are some examples of how we integrate information from the panchromatic bands with information. No, I'm sorry, with radar information with the information from the multispectral bands. Other examples that I can mention is the merger of decisions. In this module, the objective of this method is to carry out an inference, a high-level inference, not like before where it was a lower level. Here, this is a high-level inference because we're working with data that we already have, the information that we can extract and how we can combine it. In this sense, there are different groups. Some are based on probability, and that has to do with Bayesian inference, and other that have to do, there are technical methods that are based on artificial intelligence, and the final that are based on information theory. I'm going to give you some examples of those that are based on information theory. These methods, they try to combine the classifications of each of the sensors that are involved in the merger. And what they're trying to do is make decisions based on a majority vote. Now, what does that mean? We have an image, as a multispectral image, and we can extract the characteristics via a machine that classifies, that gives. We can do a more spectral classification, and we can also extract characteristics with a contextual algorithm. And what we're using here is a morphologic algorithm in order to see more regions. Both sets of information are combined into a module that merges decisions so that we have a classification that's more homogeneous. This small project we use, for instance, to determine agricultural types, different types of crops. Some are cacao. We can separate them and determine the regions of the cropland. And in this study afterwards, this was done in 2007, we were able to corroborate In Tabasco, in the state of Tabasco in 2007, they had a problem with flooding, and we were able to determine how many crops had been damaged. As I was saying, these integrators of information can work with blurry sets of information, because you come up with a set of rules, and then you set the rules by decisions or by majority to be able to combine the results. The results are fairly good when you already have better classifications. And as you can see, for the separation of land coverage, you can see that on the images. Well, I really wanted to just introduce you a little bit to this data fusion context and information integration. The community that is devoted to data integration from 2006 to date is really driving the research on these data. So in 2012, Data Fusion Context makes available to academics a set of sensors, where one of the ideas is to understand all of these combination processes, how we can work with them, and how we can understand information. So if you see here, they put data from worldview and LiDAR, and the main results that they obtained was to get new metrics for evaluation urban density, and taking into account the horizontal and vertical characteristics of the city where they were made available, the images were made available, and including they were able to detect changes in densely populated areas. So in conclusion, what do we really need? We need to develop methods that take into account the difference of the various sensors, of the different sensors, how they're participating and how they're collaborating one with the other, and how they can be complemented. We have to develop more methods that will make this task easier. It's important to always have the analysis of the coherence of each of the sensors, and also to see the coherence in the results phase. And the use of multiple types of sensors can increase the adjustment with which an object can be observed and characterized. So in conclusion, the systems that fuse data from various information sources could be more robust than those that depend on just a single source of information. Thank you.
We want to thank Dr. Caloca for her presentation. We're short in time. We have the possibility to make a couple of questions. If you would like to ask a question, you can go ahead and say your name, please, before you start. Una pregunta para la primera oradora. La psicología cognitiva es un área muy complicada. Hemos trabajado por este tipo de psicólogos cognitivos por 10 años, buscando el impacto educativo de nuestros productos. Una de las cosas que hemos visto es la retención en memoria a corto plazo y la retención en memoria a largo plazo. Es un área difícil. Me pregunto si han hecho algunas mediciones en los resultados de los componentes educativos que han desarrollado. La segunda pregunta, si está familiarizado con las teorías cognitivas de Gardner, en las que hablamos de las múltiples inteligencias. Si es el caso, ¿cómo encajan con el trabajo que usted está haciendo? La división de el lado derecho e izquierdo es solo el principio. Hay que ver qué esto significa en términos de material educativo que nosotros producimos. Y al producirlo, ¿la gente realmente tiene una retención de lo que aprende o solamente les atrae por un momento y luego lo olvidan? Le repito la primera pregunta. La primera pregunta. ¿Se lo están traduciendo? This question is for the second speaker. I'm attracted by the idea of the different sensors. I imagine that they cost, or is it for free? How do you handle it? And with INEGI, what do you do if you have a software to capture those images? And I understand that satellites were sponsored by the government during Carlos Salinas, and they are owned by the government. Is there a cost? You sometimes have to pay for those images. Well, I think. Creo que necesitamos que repita la primera pregunta. I will start by answering the second question, and then we will go back to the first one. I need you to repeat it. The laterality that I mentioned, I gave an example. It's an important concept, an important basic geographic concept. And it is constructed before 7 years of age. In the cognitive aspect, this laterality, that does not exclude the fact that this laterality is developed and worked during the entire elementary and secondary school years. I think that your question refers to the fact that we have two ways of teaching. The deductive one, we teach a concept, and then we apply that knowledge with a practical activity. And then there's the induction, where we start by placing the student in a real situation in which he will need to choose and solve a problem, make decisions. And since we are in a world in which, due to our technology revolutions, humans have to be prepared for decision-making processes at very short periods of time with some reflection, with a rational capacity that entails mental training. So the conclusion is that the important thing is to place this education activity in projects, in real situations, real geographic situations, I mean. I don't know if you could repeat the first question. Or, well, they will pass to the other one.
Look, I think that one of the things that's important in the presentation is that I wanted to give you a methodological framework. One of the good things is that many of the images, like Landsat, for instance, is free or open, and you can conduct this sort of analysis or research. There are also many images like MODIs that in that sort of format. And in addition, one of the important things is that there's also open or free software that you can use. For instance, the French Space Agency has Orpheus, a software called Osware. A software called Orpheus, and there are also various tools that I just mentioned that are free. And we use, yes, it's true that in certain processes at Centrogeo we use tools that you have to buy, like NV and PCI, but we also use tools where we, like MATLAB, and sometimes we work with C and open source. So we work a lot with open source where we download tools and we develop tools. The part that I was talking about is that this data integration community is to try to understand all of these high-resolution data, and sometimes it's difficult, yes, to get these data, but they're made available to the scientific community every year when you have a research proposal in which you register on the IEEE's webpage, and then they make all of this information available to you so that you can begin to understand how to use the information. So there are many ways in which you can get information for the research end of it. So the most important thing, I think, is that we create these capacities to be able to build new methodologies, and I truly think that that's where we are, where we can develop many, many things. Okay, one more question, because well, for Dr. Pilar, good afternoon. I'm a professor at the UNAM. At your presentation, you said you gave some specific examples as to what your work group has done to somehow link the spatial topic to students' development. And when you were talking about the place names and the municipalities, what geospatial information did you end up using for that, to be able to develop this educational activity with your students? Well, the geospatial information that we used was precisely maps that the Cartographic Institute of Catalonia makes available, or make available in open source. So it's freely accessible. Since it was a case of a very large scale that we were dealing with, we were talking about a municipality, then what we did was basically work with orthophoto maps, because they're much more intelligible to them. And on the orthophoto maps, they would draw their location, and then from that, then we geo-referenced in a cumulative manner, so that we marked each place name, and then they related it to a final map. But the objective of the project was not just geo-referencing. It wasn't just that. The idea was especially that based on the spatial experience from that research that they had to do, that they felt like citizens of their town and of their municipality. That was the point. Okay, well, we are now going to give our speakers a token of recognition. Dr. Pilar, thank you very much for your participation, and Dr. Alejandra, also thank you very much. And that is the end.